Hey, welcome back. So today I'm going to begin a new series on building my M54 for my e46. Hopefully hit 1,000 horsepower on the e85. And I think the most important step of building any engine is right behind me, the cylinder. We're going to be taking the cylinder from this exhaust and intake side into this fully ported cylinder from the exhaust, intake, and combustion chamber. But first, we're gonna have to start somewhere, and that somewhere is on the exhaust. Here's the OEM exhaust port. Take a good look at that. You could just see the jagged and abrupt transitions. There's not really much thought and flow into the cylinder head. You gotta keep in mind when these cylinder heads are being developed and designed, the main priority is, I guess, manufacturing costs. And this engine originally made 225 horsepower at most without boost. So there's a lot that can be done to improve flow. Here's after porting. You can see nice smooth transitions throughout. Nice short side radius. Here's the exhaust port. Nice smooth transitions throughout. Nice radius as well. The main goal isn't just to make everything bigger, you know, that's essentially the last thing you want to do. There's a lot of thought that goes behind porting a cylinder head that not many people talk about. So why should you port your cylinder head on your M54? I think it's very important so people understand that engines are just huge air pumps. The main goal is try to get as much air and fuel into those cylinders within fractions of a second, especially at 9,000, 8,000 RPM. And from the factory, especially on the M54s, it's not S54. The main goal was not power and efficiency. Well, efficiency maybe. But all these cylinder heads, when they're being designed with a set of parameters. So for the M54, it's probably low in torque, low RPMs, fuel efficiency, and main and most important thing, lower manufacturing cost as much as possible. A lot of people tend to argue that cylinder heads are perfect from the factory. They're not. I mean, there's shift within the castings and all that, but just from a design standpoint, this versus that are not the same thing from the design standpoint. One was designed, as I said, for efficiency and lower costs when manufacturing. Unless you have like an S54, you can get improvements on those, but it's very hard. Those are engines that were designed for high RPMs, high horsepower and whatnot. But when you're dealing with, I guess, commuter engines like this, they're not really, prior was not horsepower. So there's a lot to be gained. And then since your engine's running more efficient, less boost pressure is needed. So there's overall less stress going throughout the engine. I wouldn't say the forge or the internals aren't facing any more forces. They probably are, because you're feeding more air into the cylinder and more fuel to get more energy out. So there's going to be more force in there, more stress on the components. But if you're somewhat competent when using tools and grinders, I think you could put your head at home, just following some common simple rules. But that's what I'm gonna be attempting. I'm no professional. This is probably my second cylinder head. The first one I messed up. So I learned a lot. So now I'm gonna be showing you what I learned that works well with the M54 cylinder head. So starting off with the tools that you need to get started on porting a head. I think the tools are very important. A Dremel 200. Common mistake. I see a lot of people using the small burr with this smaller Dremel to port. I wouldn't recommend it. It's just making it a lot more difficult, and you won't get those smooth transitions that you're aiming for. That's why I would recommend this key right here. Here's a part number on that. This is the workhorse, and to match that, I would go with the speed controller. Me personally, I like keeping it around 60 volts. Not too fast, not too slow. Any light, doesn't have to be a Milwaukee light. This Harbor Freight abrasive sanding kit comes with two of these chucks or shanks. That way you can sand down your port. And here's the main workhorse of the set as well. This is trying to remember their name, but it's a 5/8 carbide single spiral, single cut burr. You can see it's a lot bigger than the Harbor Freight one. That's going to give you that nice radiuses that you want to go. Then to go along with this, I would recommend the 3/8 spiral burr double cut. Don't think you have an option, but those are the two main ones. Some custom parts, I guess. 3D printed this ball, so you could port your guides, and a template for your exhaust port. And then last but not least, a Sharpie to go along. So the first step, once you have everything cleaned off and you remove the studs, I decided to, through research and development, I decided to keep these two lengths the same. I also decided on increasing the width, as you can see here. What a lot of people would do, the first step in their mind, would be to grab your gasket and just Sharpie it out and just hog out the whole entire exhaust port. That's probably the last thing you want to do, especially on a turbo application. I'm supercharged, so it does matter, but it hurts less. It's you want the exhaust gas velocity. You also want to increase flow, but you also want to increase gas velocity. So when you're pushing more power, there's going to be more air, thus more exhaust, right? So it'll be more restricted, so you have an increase in gas velocity. It's a tango. You don't want too much gas velocity, but you also don't want too much what do you say, exhaust CFM, because then it just means you have a slower gas velocity. So it's a balance. And I found that for my supercharged application that I took the original measurements of the gasket, scaled it down to the size. So you can see right there. It's just slightly making it bigger. You see that? Right here. Boom, just like that. So that should increase gas velocity. Well, yeah, not increase, but it'll decrease it, but the increase of horsepower or in the cylinder or energy will displace that. If that makes any sense. Also, you're not just porting the outside. A lot of people just port this and then stop, but that's not the end of it. So I'm gonna get this Sharpied out, and we'll see that. Just eyeball it, honestly. As I mentioned before, there's a lot cast shift, so not everything's gonna be perfect. All right, so I'm gonna mark this out real quick. Just take your Sharpie, line up as best as you can, lining up with this lower edge, about there. Give it a nice eyeball, or right there. And make sure it's flush. Yep. So next what you're gonna do is take your 5/8 burr and your Makita, and then you're just gently gonna carve this out. Not gonna put too much force onto it. You're gonna see, but the whole point is just to get that first outline, the port. Then you can start porting in here. You're gonna start out here first. It takes a while, especially on this low speed setting. The reason why I do low speed setting is so I can get that nice finish, as you can see. You want to start at the center so you can start building out the curve. But just barely, I'm not putting any pressure. So once you're done getting the general shape, we're gonna start focusing on the inside. These two inner walls, you can see still has like the original shape. You're just gonna grind that out consistently through until it's wider than this section. Then you just leave that alone, like here. So let's get started. So once you're done getting this general shape, you're gonna take out this 3D printed tool. You can make one at home if you're a 3D printer or just any, I think it's a 28mm sphere. But it's essentially just the size of the port. You're gonna use this as your guide. As you can see, it doesn't fit through. So the goal is to make this fit through, focusing on only taking off material down here. You might have to take off, you will have to take off material from the roof right here. You see how that radius is a lot shorter? You're gonna do that by digging into this. You get a nice smooth radius throughout, but mostly focusing on here. Don't take off too much material. This is essentially the roof. This is the bottom. It's flipped upside down. And then eventually you'll get over here and you just grind this, and you're gonna grind this side out. So that's what I'm gonna do. Oh, and then just focus on one port at a time. So once you finish this side completely, you can work on the other side. Because if you go from here, 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 it's just gonna mess up the flow, because you're gonna feel the jaggedness or the little steps that you make. But yeah, so I would just take your time, grind out some more, check again, check again, check again. It's a long process, but you end up with a nice, consistent port like that. So once you're done porting the inside of the exhaust port, as you can see, I did a little time jump. I did the rest of the ports. You want to start on the other side and should end up with something like this. Then you can lift the cylinder head on an angle. You want an angle. This is about, I think, a 2x4. So just 2x4 on one side. And that way you have easy access to the bowl. The bowl is probably going to be your biggest gain. So it's very important that you get this, I guess, done correctly. So we're going to go back to this tool. and that's just gonna fit down there. But you see, it doesn't fit. Also, it's a lot smaller. It was supposed to be like an exact fit, but 3 printer tolerance variation is not that good. So it should do something like that. Currently, we don't have that. You can see, focus. We have some on this edge that we have to take off, and over here. Your cylinder head might differ because of casting variation, once again. So that might depend on where you're gonna take off material. So just be vigilant on that. But yeah, so the whole goal is just to keep a nice, essentially imagine the pipe, just a nice constant radius throughout. This is because that would have the least, I guess, frictional losses off air. And that should theoretically give you the most flow. Obviously, other ports designs differ, but that's what works for the BMW cylinder head. So we're gonna do that right now. You just use the same tool, the 5/8 burr. Just don't go up and down, side to side, side to side. Slowly removing material. It's better to remove not enough material and go back and redo it again than remove too much material and good luck trying to add that back in, you know? So yeah, just back and forth. It's gonna take a while, but keep on tracking. I'll show you a quick trick that I do in a bit. So one thing you may have seen me doing is pulling the ball in and out a few times like this. And the point of doing that is that you see on the side, hold on, right there, you see this darker shade around this area? And then the same thing right there. Those marks, darker marks, tell you where you need to focus on, so you don't remove too much material. So that's what I'm doing. Also, don't forget to blend the inside of the wall here, and then use your most important tool that you have. It's your fingers. So just use that feel. So like right here, I can feel there's a little ridge. So I'll just hit that to make a nice smooth transition. Just don't be afraid to put your finger and feel around. So yeah, I'll get back to you when this is done. So now that we're done shaping the port, we can work on smoothing the port out by sanding, which should be the easiest part of this job. Should be pretty quick, especially since we used the low speed with the single cut. So you get already smooth edges. You're just removing all those peaks and valleys. I recommend using this because it's the cheapest one. I think it's set Harbor Freight. I'm going to be using the 120 grit. As I said, we don't have to go aggressive, so the 120 should be more than enough. But I'll talk about later. But on the exhaust side, you want it as shiny and polished as you want. You can go through the extreme of getting it polished, like with the buffer, if that would focus, and buff it and everything. But honestly, I mean, we're talking about fractions of horsepower gains. And I guess it maybe helps prevent buildup because it's so smooth, but I'm not too sure. But I'm just gonna hit it with the 120 and call it a day. As you can see, I already did the other ports. I took a little break on getting the rest of them, so these are all done. Just gonna focus on this last port. You can see how the light reflects. Should have a nice even reflection. That kind of, you see how the light starts at the middle of the guide and eggs out here. That means you did a pretty good job. This one's kind of rough, but we'll fix that with sanding, you'll see. But yeah, so essentially what you're just gonna do is keep it the same voltage, 60 volts, depending, don't know RPM wise. Now what you're just gonna do, let it guide itself. You're not gonna push, you're not gonna corner it or anything, you're just gonna, just like that, and you're just gonna let it do the work for you. If you're sweating while using a piece of, I guess like a machine or something, you're doing something wrong. At least that's what my shop advisor says, but hey, that's what I know too. So I'll get to you in a bit. So now, but not least, you have to get the bowls, which is pretty straightforward. You're just gonna go in the circular motion, trying to stay in one spot, and then try getting these lower regions right here, and then that should be it. We're almost done, but what I do is I grab a piece of sandpaper, just any kind. Feel these edges, these are pretty sharp, so all you do is just go around, dull them up a little bit, add a little chamfer, and then that should be good, preventing hot spots. But yeah, this is how your exhaust port should end up. It's ready to go to the machine shop. Now I still need to do the combustion chamber and the intake, but exhaust side is done. Oh, and then if you're, I forgot what this is called, but if this fin is too sharp, like on some of these, just hit with the sandpaper, dull it up, and that should be good. And then when you bring it to the machine shop, make sure to pick up a set of brand new valve guides and get those replaced. But other than that, I'll see you in the next video.